Okay. Hello, everyone. Welcome to Lego training second sessions. We will start in around 4:10. So we will wait our friend for at least 10
Hello,
minutes.
hello.
Yes, hello.
Clear nhỉ mới thôi clear mà.
Hello, good afternoon. Good afternoon, everyone. It's 10 past 4, so I guess we can start. We have less participants compared to last time. We will start anyway. I hope you are all doing well. I hope you can hear me well and see me well.
Yes, I can hear you.
Okay, seeing me well is not very important today, and last time neither. But I hope you can see the other account named Robot. It's another camera. Uh, is there any teacher here who is to pin the camera of the robot for your students? The rest of the time, I will be sharing my screen with the robot account as well. Uh, yeah, so my camera is useless for today, but use the other one. Okay, that being said, at the end of the last session, I gave you a kind of a homework or a challenge. Before we start, out of curiosity, anyone tried to do it? You can enter in the chat, and then I will explain you what we are going to do today. Okay, I don't see any answer in the chat. So, okay, I will explain you what is the plan for today. Uh, Actually, I will present you some examples of solution. Okay, example of solution, because you can find many other solutions to this sort of problems. And you will see the solutions are really not perfect. The idea is also that you can improve them uh, later. Okay, I will explain you what are the limits of my examples, so you may have other ideas. Okay. Um, Please do not hesitate to use the chat if you have any comments during the meeting. So today I will present you example of solutions for the three challenges. I will remind you what were the challenges. Again, do not hesitate to interrupt me if you have any comments, questions about the example of solution or any thought. And after that, I will, depending on the time, I will present you some other things. You see, I brought the sumo robot ring that was used by some of you, I guess, a few months ago. So I will use it to show you other examples if we have time. Okay. All right. Still no comment in the chat, so I will re-explain the first challenge. It was only, as you can see on my screen, about the robot structure. Okay. It was not about programming, not yet. So we had to design something that would contain the the controller, which is the EV3 computer. By the way, if you were not here last time, you can also let me know in the chat. I will adapt the presentation. But for the moment, I assume you were here last time. If you are not, please let me know. You had to include one controller and then two motors and then 3 or 4 wheels. You were quite free on this, including 2 wheels being connected to the motors. Okay, that was the idea, and you have many solutions to do that. So I will show you 2 examples for that one. For this one, you can pin my main camera. Okay. The first one was not made by me. It was made by one of my students. Okay, I hope you can see well. So we have the controller here, and it's hard to see. You have two motors that are fixed directly on the controller, and then the wheels are fixed directly to the motor. Okay, I can remove the wheel. The wheel has been connected directly to the computer. Okay, to the motor. Sorry. Okay, like that. Same on the other side. So we have very simply two motors fixed to one controller and two wheels connected to the motors. Okay, and then the goal was to add a last wheel or two last wheels that were freely moving. So we have an extra wheel here that can rotate freely. Okay, this one is not moved by any motor. It will only follow the movement. Okay, I hope you could see that example. Now I would like to tell you why it's not so good. It's respecting the condition, but maybe the client who made the requirements forgot about something. So let's have a look. If you have three wheels like that, it might be difficult to turn left and right. Okay, to go straight forward, it will be pretty easy. You will rotate the two motors, that will rotate the two wheels, and the last one will only simply follow the movement. Same if you go backward, but if you want to try to turn right or left, it might be difficult. Imagine if these two wheels controlled by the motor are trying to create what we call rotation, okay, turn left or turn right. For example, I can ask this wheel to move in that way, the other one in the other direction, so that the robot should rotate like that, okay? However, if I do this, you can have a look at this wheel. And during that movement, you see that wheel will not be able to spin freely because it's trying to move in that direction, okay, or in that direction. Okay, so the wheel is blocking the movement, completely blocking the movement of, oops, the movement of rotation, okay? So in order to avoid this, we have different solutions. First, we have the solution of real cars. Okay, when you try to turn, we use something called a steering mechanism. I can show you one quickly. Okay, so it starts to be a bit difficult, but this is the kind of thing you have inside cars. Okay, you turn this wheel here, and it will turn right or left. Okay, and then the free wheels will just follow the movement of rotation. Okay. So you can see the mechanism here. It's a bit complex. We use 90-degree gears here. You might see behind. Okay, so that was a bit difficult and not necessary. The other idea that we are not using in cars, not yet, we might be using this in the future. It's to replace the wheel, the last wheel that was moving free, by a simple ball. Okay, as you can see here, and this one can rotate in every direction, right? I mean, not up and down, but if I'm turning right or left, this ball will only follow the movement freely. Okay, not only forward or backward, but also right or left. Okay, that's the idea of this ball, being able to rotate in every direction. And you know, wheel can rotate only around one axis. So for the other challenge, I will reuse that solution. The other challenge were more about programming. Okay, if you have any questions, you can ask me, or any comment. So yeah, I just wanted to present you that kind of steering mechanism inside your car. It's I don't know if we have time to talk about this. Inside cars, it's even more complex than this, because when you turn left, for example, the wheel on the right need to turn a bit less than the other one. So we need more gears or more complex system. Okay, but let's not worry about that. You might study that one day. For the moment, if there is no comment, we can go to the challenge number 2. Number 2 was about coding. And okay, let's have a look together at this challenge. I tried to write it in a programming manner. Okay, like, program the robot respecting this requirement. We have 2 requirements. While nothing is in front of the robot, we will move forward. Okay, while nothing is in front of the robot, we will move forward. So that means we will need to check if there is something in front of the robot. Right? For that, we will use a distance sensor. So we need to add it to the structure that we built in the first challenge. Okay, I have this structure, and you see that is a distance sensor, which is connected. You see that cable, yes, connected to the sensor input, which is here the number 2. So in my program, I will have to say that the movement will depend on what I receive on the input number 2. Okay. And the other case, the other requirement, if something is in front of the robot, so I will use the same distance sensor. If there is something in front of the robot, I will turn left until I don't see anything in front of the robot. Okay, so the robot will move straight forward, and when there is an object, an obstacle that is detected, it will turn left until it doesn't see anything anymore, and it will move forward again. Okay, so we have to manage these 2 cases. I will show you the code. Okay, I hope you can see my new window. So that is an example of solution only. You might find many other ways to solve this problem. Okay. So I managed the 2 cases regarding the, you see, input sensor number 2. Okay, so this one represents the distance sensor. I will zoom a bit. Okay, it's a bit laggy. All right. Okay. So I have my sensor number 2, which is measuring the distance. I am checking the condition if the distance is greater than 15 centimeter. Why 15 centimeter? In the challenge, it was not really specified. We just said if there is something in front. So I put 15 centimeter, you can put 5, 10, 20 centimeter. You cannot put less than 3 centimeters because the sensor is not able to measure a very small distance. Okay? So that's why I put 15, but it could be different. When the distance measured by the sensor number 2 is greater than 15 centimeter, then I will stop the sound, I will stop the movement, and I will start moving straight. Okay. So for the moment, the only important thing is this one. If there is nothing in front, we move straight. What does start moving mean? You remember last time I told you we have to use motors, right? A, B, C, and D. Here, what I did was using, when the program starts, this block to combine motor A and B to create what they call a movement. And this first block here allow me to just say moving forward, backward, or you see here turning left, for example. I don't need to control the motors individually because I use that block. Okay, so let's imagine when I click on start, when the program starts, it will first create that movement A and B. Motors are connected to create a movement. And I will say that the speed of the movement will be 50%. Okay, half of the maximum speed of the motors. That is when the program starts. And then we have two cases during the robot movement. We have the case where there is nothing in front. In that case, we move straight forward. And we have the case where we have something in front, less than 15 centimeters. And here we will move left. This is what was asked. If there is something in front, we turn left. So this is what I did here. Why am I using this stop moving at the beginning? I just want to avoid any confusion from the robot. If I don't use it, I will be moving left at some point, and then I will give the order start moving straight. But I prefer to say first stop moving left and then start moving straight. It might not be necessary, but I prefer to use it. And how about the sound? This was not part of the challenge, but I want to show you it's also possible from your robot. Okay, here I will play a sound when the distance is less than 15 centimeters, when it detects something. And I will stop the sound when it's not detecting anything anymore. Okay. Okay, so we have our program. You see here, I'm not connected. It's a red LED. I need to turn on the robot. And we will do the connection together. So here I will connect with Bluetooth. You can also use cable or SD card or Wi-Fi, but here I will use Bluetooth. It needs some time to turn on, so during that time you can ask me questions if you have. Okay, I don't see questions. I will click on connect. And you see, I have different robots available. I will click on that one, Paragon. It's the one I'm using now. And you see now I have a green LED. It means I am connected. I have the feedback from the robot. You see the motor A and B. And then we have the distance sensor. Right now, the distance sensor is measuring around 30 centimeters. But there is my hand not far from it, so now around 10 centimeters. And number 1 and number 4, they are color sensor that I will use later, but not for the moment. Okay, so you can only look at this distance sensor and the two motors. Okay, how do we play this code? I can click here to or you have a delay on the screen. So this button is used to download the file on the robot. And this one play will download it and play it. Okay. So I will use this directly. I will put the robot on the ring, and then I will play it. So you might show the ring to your students. If it's too small, you can pin the camera. Okay, I hope you could see a bit. So when nothing was in front, the robot was moving straight forward. The speed was only 50%. If I put 100%, it might be too fast. And then when I was putting my hand in front of the sensor, it was making that sound. I don't know if you could hear it because the microphone is a bit far, and then it was turning left. Why is it not stop moving? Because you see, I am using the stop moving command in two cases. But whenever I'm using stop moving, just after I am saying start moving. So it will stop moving, but start moving just after. So it will never stop. It will never stop completely until I stop the program. This, I explained last time. Maybe you were not here, or it was not so clear. These two yellow blocks here and here, they are called events. The event can happen more than one time. Okay. They might happen, well, as many times as we want. So even if this is played one time, the distance is more than 15, it will stop moving and start moving straight. But the robot is still measuring the distance, and it might be played again later. Okay, these three parts are played, we can say, separately. Okay, we are checking when the program is started. This will happen only one time, but the two others, they can happen many times. Okay, as long as it's greater than 15 or less than 15, it will trigger this event or this event. Okay, that's why it was not stopping. You might wonder why I did not manage the case where it's exactly 15 centimeter. Well, it's because it's almost impossible to have exactly 15 centimeter. I mean, in real life, there is always a small mistake, small error. But even if we could measure 15 centimeter exactly, well, it will just continue moving, and then it will be more than or less than 15 centimeter. So the case will be managed all by itself. Any other question? If no, we can go to the next. Oh, can the movement be controlled by the wheel rotation? Can the movement be controlled? It. Oh, instead of using this start moving. How many times? Yes, yes. Here, I decided to use start the movement and stop the movement. And I was using the events from the sensor to determine if I also use this. Okay, if you don't know, if you know exactly how much you need to move, you could use this. Move forward for 5 rotation, like a 5 time 360 degrees. Or you can be more precise, let's say 45 degrees. Or you can use time as well, okay? Move forward during 45 seconds. That's possible. If you know exactly the distance you need, it's possible. And so here it's controlling the two wheels at the same time, simultaneously. But you can also use them separately with the motors. So individually, you can say instead of setting a movement to A and B, you can say I will move the motor A for 5 rotation, and let's say the motor B in the other direction for 1 rotation. Okay, we can imagine many cases, but this movement might be easier to use when you have events. One risk with this solution here, the two events, the two instructions will not be played at the same time. A will run clockwise for 1 rotation, and at the end of this rotation, B will start and run clockwise for 1 rotation. They will be done one by one. If you just use start moving or move forward for 1 rotation, they will move together. So you can use this blue, the motors individually, but it might be harder to manage. I think I used it for the next challenge. Okay. So we will go to the next challenge. I will show you my. Okay. All right. Challenge number 3. Oh, there is not much here. Few instruction. Design, build, and program a robot that is able to detect and follow a black line that is on the ground. Okay, here the challenge is not very clear, so that means you have many ways to solve it. I will just give you one example of solution. Okay, I will zoom a bit. Okay, this time I haven't played any sound. So I have. You will need some imagination. We have a black line that we need to follow. And I will show you again, my robot got 2 color sensors. Two color sensors. They are here and there. Okay, these red dots here, they are color sensors. And the black line is quite thin. It will be in the middle. Okay, when the robot will move forward, the black line will be in the middle. But the black line might turn right or left, and my robot will have to follow it. So I have to manage the different cases. Sometimes the black line will not be in the middle, but here, here for me it's on the right. For you, okay, it looks like it's on the left. So let's say on the left. No, I should say on the right because I really need that later. So if the black line is detected by this sensor on the right, my robot needs to turn left to. Oh, sorry, my robot needs to turn right. I'm confused with the mirror camera. Okay, so I need to turn like this, right? Turn right. And if the black line is here, I need to turn like this. Okay, so we have these 2 cases to manage, because the last case is when the line is not detected at all. And I will assume that if the line is not detected, it is because it is in the middle. Okay? I will not manage the case where the line is outside. Okay, it's not part of this challenge. We have to follow the line. So if the line is outside, we already lost. Okay, then we can imagine the robot try to explore to find the line again, but I will not do that here. Okay. So we have our two color sensor, 1 and 4. And we have to manage the two cases. So first, when the program starts, we create the movement with A and B, the same. Set movement speed to 30%. It will be slower this time, and it will move straight. It will start moving straight. And here I manage the two cases that I presented. First case, my color sensor number 1 detects a black color. So I am detecting the black line. And the color sensor number 3 is not detecting the black line. Okay, so that means only the number 1 is detecting the black line. And in that case, I will say, please turn left. Okay, the robot will turn left until it will be played until this is not detected anymore. That means we are back in the middle. And here it's the opposite. When the sensor number 1 is not detecting black and number 4 is detecting black, in that case, the black line is on the other side, and we have to move to start moving right. I hope it's okay. I will move the camera so you can see the black line, the camera of the robot, and we will try this one. So I will play it. Oh, I need some feedback. Okay, I hope you could see a bit. So what you saw was the robot following the black line, and I think you could observe two things that you might not have expected. I tried to not explain that before the demonstration. First, we saw that the robot was never moving straight forward, except the very beginning. After that, it will only move left or right, or left or right, or left or right. Okay, forever. Because it will never be able to be in that condition again, because that is triggered only one time when we start the program. Okay, so it will just move left and then right and then left and then right, etc. The other thing that you might have noticed at the end was that when the robot was leaving the black line, it was a bit lost and it was turning right all the time. Why? It was not detecting any black color. Okay, and yet it was turning right. The reason is that the last thing that was started before leaving the black line was this event. The event is not move right for during 3 seconds or move right for 3 rotation. The event is start moving right, and we will just never stop. That's why it was just spinning right forever. Okay. But again, it was not specified. We could say that when we don't detect any black color, okay, I will show it to you right now. I create a new event when my two sensors, this and this, are not or is it? Okay. Here it's the case where none of them are black. This can happen at the end when we lost the black line, but it can happen in the middle when the black line is between the two sensors. So my example will not work except if I had another condition. We could create if condition if the black line is not detected during a certain amount of time. We could do that. Okay, to make sure we are not just having the black line in the middle. Okay. But I'm checking the time. Okay. Is there any question from other participants? If there is no question, we can stop very soon. I just prepared a last example, a last demonstration with using the ring for those who played SumoBot. And you had the programs better than mine, so I will show you that one. Just as an example to give some ideas to those who haven't played. In that example, I start a movement that is a bit random. Random, it means the computer will decide if it's moving forward or a bit left or a bit right. It will be decided by the computer. I like to do this. That will it means my opponent might not be able to plan my strategy because my strategy is random. It's not really planned. Okay, and then I have this to detect if one of my sensors is detecting the white border of the ring, the other one for the other border of the ring. And when we detect the border of the ring, we move slowly counterclockwise, so it will turn back. Okay, that's the idea. The rest of the time, when it's not detecting any white, it means it's the black color, it will go forward, but it will rotate a bit randomly. And the last case, if the distance sensor detects something, it will go faster, straight forward to push the other robot out. Okay, just one idea that we can test together. I think the robot is ready. I haven't tested. So let's see, you see it's rotating a bit because it's random, and then it's turning back. Oh, it died already. So I have to check my program. And I plan to improve it step by step with you. But we might stop here if there is no question. I'll let you 5 minutes to write any questions or comments if you have. And then since it's almost 5, maybe you want to have your weekend. So let's see if we have any questions. Okay. I see we don't have questions. So I think we can stop here. If you want more details, so here it was online lesson. It's not easy to learn online, especially when it comes to robotics. So you might want to contact Mr. Sulkosa or the STEM festival organizer, who are also organizing WRO. Okay, so STEM Cambodia. You might contact them because they will propose other events and more regular events, not online, but with physical participants. Okay, goodbye everyone. Have a great weekend, and you can let me know, contact me if you have any other questions. Goodbye.